Hello and welcome back to Data Center Insights. I'm your host, Emma, and today we're continuing a conversation we started in a previous episode about the impact of artificial intelligence on data centers. If you haven't listened to that episode yet, be sure to check it out later. We discussed the skyrocketing power demands driven by AI and high-performance computing and what that means for the future of data centers. But today, we're diving deeper into how to distribute that power effectively to keep up with these evolving demands. So, let's start with a quick recap. As you know, AI and HPC are reshaping data centers at a fundamental level. These technologies demand higher power densities and more dynamic workloads than ever before. A few years ago, most racks were running comfortably at around 8 to 12 kilowatts. But today, we're seeing densities soar to 40, 50, or in some cases as high or higher than 100 kilowatts per rack. This dramatic increase isn't just because of more powerful hardware, but also due to the complexity and variability of modern AI workloads, which require consistent access to vast computing resources. This puts a giant strain on traditional power distribution methods, like raised floor cabling. And as the demand grows, these traditional setups are struggling to keep up. Imagine trying to retrofit an old house with new electrical wiring. It's difficult, messy, and often not worth the effort. Traditional cabling in data centers faces similar issues. You've got crowded underfloor spaces, limited airflow, and the looming risk of overheating or electrical faults, such as short circuits and electromagnetic interference. And every time there's a need to upgrade server hardware or increase rack density, it results in expensive rewiring, dreaded downtime, and a lot of operational headaches. So, what can we do to address these challenges? We see that more and more data centers are turning to busway systems. These systems aren't just a clever workaround, they're a forward-looking solution that fits perfectly into the future of high-density, AI-driven data centers. Let's explore why busways are becoming the go-to approach for modern power distribution. One of the key reasons is their adaptability. As we just mentioned, AI and HPC are driving rapid hardware changes, and data centers have to be ready to adapt without causing major disruptions and costly downtime. Traditional cabling methods can't handle these frequent upgrades without extensive reconfigurations. However, busways offer plug-and-play capabilities, allowing you to add or move servers without having to shut down the entire system. Think of it like building with modular blocks. You can expand or rearrange your setup without tearing it down. And with the ability to support power demands of up to 1250 amps, busways are well-suited for even the most power-intensive AI applications. But adaptability isn't the only area where busways excel. There's also the critical issue of safety and reliability. In high-density environments, electrical safety is paramount. Traditional cabling can present risks, especially if the setup isn't managed carefully. Busways address this concern with solid compression connections, which ensure long-lasting, maintenance-free joints. These joints not only improve reliability, but also reduce the risk of overheating over time. And to further enhance safety, busways come equipped with high dielectric strength insulation to minimize the risk of arc flash incidents. For ongoing maintenance, busways integrate infrared windows that allow for safe thermal scanning without disrupting operations. This proactive monitoring approach means that data center operators can catch potential issues early, minimizing the likelihood of costly downtime. Another major consideration in modern data centers is space optimization. AI and HPC are driving demands for increased server capacities, which means floor space is becoming more valuable than ever. Traditional underfloor cabling often leads to crowded spaces, making it difficult to manage equipment and airflow efficiently. As you add more cables, you're essentially blocking airflow, leading to potential overheating problems and reduced rack capacity. Busway systems offer a powerful solution to the challenges of space optimization in high-density data centers. By utilizing overhead power distribution, busways eliminate cable clutter from under-raised floors and free up valuable floor space. This cleaner, more organized layout allows data centers to maximize rack density, even eliminating the need for bulky remote power panels, RPPs. In high-density environments, this means you can fit more servers without expanding your facility's footprint. Additionally, overhead busways improve airflow management. an essential benefit as cooling needs rise. Speaking of cooling, thermal management has become a top priority as AI and high-performance computing ramp up. AI servers generate over 50% more heat than traditional data center setups, putting extra demand on cooling systems. Traditional cabling can further complicate this by obstructing airflow under raised floors, leading to hotspots and increasing the risk of overheating. By routing power overhead, busways allow air to flow freely throughout the data center, significantly reducing the cooling load. This approach enhances cooling efficiency and helps maintain optimal temperatures, providing a more stable environment for your critical infrastructure. Busways are also compatible with advanced cooling solutions like direct-to-chip liquid cooling, which is becoming increasingly common for AI and HPC applications. By reducing cable congestion and integrating seamlessly with these modern cooling methods, busways play a crucial role in maintaining a stable temperature in high-density environments. Now, let's shift gears and talk about installation and deployment. In the rapidly evolving world of AI and HPC, data centers need to be agile, deploying new infrastructure quickly to keep up with business needs. Traditional cabling systems can be a pain to install. They're labor-intensive, require precise planning, and can lead to delays that impact your timeline. Busways, on the other hand, come with pre-assembled components and lightweight enclosures, making the installation process much faster and more efficient. Did you, for example, know that track busway systems can be installed up to 90% faster than traditional cable and wire systems with less labor cost? And on top of that, the modular nature of busways allows you to roll out infrastructure in phases, scaling up as demand increases without the need for a full-scale overhaul. Of course, all of this would mean nothing without reliability and redundancy. AI workloads are mission-critical, and downtime simply isn't an option. With busways, you can easily set up dual-feed power configurations, ensuring continuous uptime even during maintenance or equipment failures. This built-in redundancy allows the system to automatically switch to a backup source if one power path fails. And if you need additional redundancy, you can quickly add plug-in redundancy modules, giving you flexibility and peace of mind. In fact, you can scale the redundancy to whatever level your operations require, providing even greater resilience against potential disruptions. In summary, while our previous AI-themed episode focused on the broader challenges of AI and power consumption, today was all about how to effectively manage and distribute that power effectively. From adaptability and safety to space optimization, thermal management, deployment efficiency, and redundancy, busways provide a comprehensive solution for the evolving power demands of modern data centers. If you haven't listened to our previous episodes, I highly recommend checking it out for more context on how AI is impacting power consumption and cooling in data centers. Thanks for tuning in today. I hope you enjoyed learning about the challenges and solutions in power distribution for high-density, AI-driven environments. If you want to dive deeper into this topic, check out our blog or reach out to us at legrand.com/datacenter. Be sure to subscribe and share this podcast with your colleagues. I'm Emma, and I'll be back soon with more on the technology shaping our digital future. Until next time, stay ahead of the curve and keep your data centers running smoothly.